Hello learners. In this lecture we will see what all are the factors affecting the workability. So in the previous lecture we had seen what is workability and we tried to understand what is workability, and even we saw that what is going to happen if you want to increase the workability. It's always better that you add water, but that is not the only reason for increasing the workability. There are many other factors which affects the workability, and we'll try to see them. So the first one is that about the water content. The first factor which affects the workability is water content. We'll try to understand this in more detail. The second is a mix proportion. It depends what kind of mix you are using and the mix proportion. The third is the size of the aggregate. If you're using a bigger size of aggregate, then your workability is going to increase. If you're using a smaller size of aggregate, then the workability is going to come down. How it's going to affect that also we'll try to see. The fourth is the shape of aggregate. We have seen that we have angular shape aggregate, we have flaky shape, we have elongated, and we have uh, smooth shape, I mean the rounded shape aggregates, right? So that also affects my workability. The next one is surface texture of the aggregate. So we have a rough surface texture, and we have a smooth surface texture. So again, it depends what kind of surface texture you have. Based on that, your workability is going to get affected. So next is a grading of aggregate. Also we have seen we have gap graded and we have uniform graded, right? So a gap graded, a uniform graded is a one, I mean and we also have a well graded. A well graded is a one where the voids are very less. So again, it depends on grading of aggregates. Then is the use of admixture. We'll try to see how workability is going to affect the admixture, I mean how the admixture is going to change the workability of a concrete. And then we last is a temperature. Even temperature also will change the workability, right? Because if you have very hot temperature, then since the water will get evaporated, the workability may come down. So again, it depends on the temperature also. So one by one, we'll try to understand this in a more better way. Yeah. So first is we'll begin with the water content. So one thing we need to understand. So whenever I say workability, that doesn't mean that only water we need to improve, right? See, workability means it's about a water and cement, both water and cement. It's a water and cement paste what we have. Whenever I say workable, because if you have the water cement paste, if you have a cement paste, only then your concrete will be workable, right? If I go back, I'll go back to one of the slide. Yeah, you can see it here. Oh. Here it's a cement paste what we have. So if there is a good amount of cement paste, only then my concrete will be workable, right? So that is why whenever I say workability, it means there is a water cement paste in that, and because of that there is a workability. Yeah. So quickly I'll jump to that. Yeah. So coming to the water content, we'll see one by one. So first point is the higher the water content per cubic meter of the concrete, the higher will be the fluidity of the concrete. So again, we need to understand one more thing here. There are two terms here. So I'm using a term here. The higher the water content per cubic meter of a concrete, higher will be the fluidity of the concrete. That we have already seen. If there is more amount of water in the concrete, then what will happen? The fluidity of a concrete is going to increase. So one thing we need to understand, there is a difference between a fluidity and a workability. So I'll try to show how it's going to look, fluidity and workability. So for time being, let me write it here. Yeah. So we have two things. One is fluidity, and the second one is a workability. So fluidity means only the water is going to flow from your concrete. I'll write it here. From concrete, water will flow. Okay. From the concrete, water is going to flow. That means your concrete will be more and more fluid in nature. Okay. That means there is a lot of water in that. And when I say workability, in workability, whenever I say workability, it has to be an entire mixture of concrete. That is, whenever there is a flow of concrete, your concrete, that means the cement paste, aggregate, and water, this has to flow together. They have to flow together, then we say it is a workable, right? But here when I say fluidity, it doesn't mean that the cement paste, the aggregate, and the water has to be moving together. Here only the amount of water is more, so we say it is fluidity in nature. So that is why I've written a first point: the higher the water content per cubic meter of the concrete, higher will be the fluidity of the concrete, right? So that's the first point. Now coming to the, I'll take it out, yeah. Now coming to the second point, water content increases the fluidity of the concrete. So to increase the workability along with the fluidity, the cohesiveness also should be increased, right? That means when I say the word cohesiveness, let me try to do it again. See. So the second point is that water content increases the fluidity of the concrete. This is understood. If adding more and more water, the fluidity is going to increase. That's it. Now to increase the workability, if I want to make my concrete workable along with the fluidity, what do you mean fluidity here? The fluidity is water here. Along with the water, the cohesiveness. So this cohesiveness is going to come with the help of a cement. Okay. Yeah. Also should be increased. That is, whenever you try to add more water, the same amount of cement has to be added. For example, yeah, give me a minute. Yeah. For example, let us say I have a water of 100 liters and I've taken 200 kg of cement, right? So what will be this water cement ratio? Let us say the water cement ratio. How do you find the water cement ratio? It's very simple. 100 divided by 200 is what you need to do. Okay. 100 divided by 200. So the water cement ratio comes out to be 0.5, right? That's it. So this is my water cement ratio. So in the next mix, if I try to add more water, now instead of 100, let me try to add 110 liters of water. So this is in liters and cement is taken in kg. So in the next case, let me try to add more water. So I'm increasing it by another 10 liter. So it is 110 liters of water. So here I'm increasing only the fluidity. But if I want to increase the cohesiveness also, along with this, I have to increase the cement content also. So next time, instead of taking 200 here, I should take how much? 220. So as a result of that, what is going to happen? Again, you do the water cement ratio, 110 divided by 220 comes out to be 0.5 only, no? So now what is happening? Even though you have increased the water here, along with the water you have increased the cement also. So as a result of that, the cohesiveness is also increased, right? So that is the meaning of cohesiveness. If you're increasing only the water, you're actually increasing the fluidity of that. So along with the water, you have to add same amount of cement paste so that the ratio remains the same, and that ratio is called as water cement ratio, right? So this is the meaning of a second point. Yeah. So hence, along with the addition of water, cement paste should be added in corresponding ratio so that water cement ratio can be kept constant and workability is increased, right? This is how you have to increase the workability. If you want to increase the workability, along with adding water, same corresponding amount of cement should also be added so that that water cement ratio remains balanced, and as a result of that, the workability is going to increase. Yeah. Now you can see it here. To put it in a better way, see in the first case, so in the first case, you can see here there is a lot of water added, right? So that means your concrete is very fluid in nature, right? Now what you can see, the water is coming out, whereas you can't see the aggregate and the cement, right? So there is a lot of water here. So here the fluidity is more. This doesn't mean that your concrete is workable, right? This concrete is no more workable. I mean, even though there is a lot of fluidity, it's not workable in nature. But look here, here there is a fluidity. Along with the fluidity, there is cohesiveness also. That means when I'm making my concrete fall here, yeah, so when I'm making my concrete fall here, you can see the aggregates, you can see the cement paste and the water, everything is there. That means you have a fluidity, and along with the fluidity there is cohesiveness also. And now this is called as workability for me, right? So this is how the um, entire meaning of workability is put up. So whenever you try to say workability, it has to be fluidity along with the water. There should be cohesive, so that this entire mixture what I'm getting, no, it is acting as a one single unit. But here what you can see, the water only, you can see the water here, you can't even see the concrete, and you, I mean, you can't even see the aggregate and all, right? So this is fluidity in nature, right? So this is a basic difference between fluidity and the cohesiveness, and this is how the water content will affect the workability of the concrete. Yeah. So next, let me show you a small video here. Yeah. So you can see here, so already this concrete has enough fluid, enough water in that, and this is a very good mix, right? But over that, what is happening now, there is a lot of rainfall happening. Now what is happening? Water content is increasing. If water content is increasing, now again what will happen? The strength of this concrete is going to come down, right? So you should not do all these things in the site during the execution, right? Yeah. And then there is one more point that we need to understand is about the in the previous lecture I told you that if you try to add more and more water, what is going to happen? The strength of the concrete is going to come down. So there is a relationship between it. According to Duff Abram, the relation is that, let me try to write it here. Yeah, give me a minute, I'll write it here. Yeah, so let me draw the graph here. So the relation between the water cement ratio. Okay, so this is a graph what I have. So this is my strength of the concrete. I'll write in this way, strength of the concrete on this axis, and here I'm going to write on the x-axis, I'm going to write water cement ratio, right? And the graph is something like this. Now what you can understand from this graph, if your water cement ratio is increasing, if the water cement ratio is increasing, then what is going to happen? The strength is also going to come down, right? You can see it here from the graph. This is how my graph is. Let me even put it in a better way. Give me a minute. Yeah, so you can see it here, right? So the x-axis I have plotted, it has water cement ratio. So this graph is given by Abram. It is given by Duff Abram. So I have a strength on the y-axis, and on the x-axis I have water cement ratio. Now, if the water cement ratio is something this one, right? Let us say the water cement ratio is somewhere here. That means along this, the cement ratio is going to increase, and corresponding to this, you are going to get the strength. So if my water cement ratio increases, what is going to happen? The strength is also going to come down. So that is why, as far as possible, when we do the design mix, we should try to keep the water cement ratio little less. Okay, if the water cement ratio is less, let us say it here, then what is going to happen? The strength will be more. And let us say if the water cement ratio is somewhere here corresponding to this, okay, then what is going to happen? The strength is going to increase. So that is the reason whenever we try to do the concreting and all, we don't try to add external water, because if you're trying to add more and more water, then your water cement ratio is going to increase. If your water cement ratio is going to increase, then what is going to happen? The strength is going to come down. So that is the reason I told you, whenever you try to add more water, make sure adding corresponding amount of cement also, right? For example, I'll take another example for that. Let us say adding a, I have a 100 liter of water, and I have a 200 kg of cement. So what is the water cement ratio? If you divide it, you are going to get zero 0.5. So zero 0.5 is my water cement ratio, and let us say 0.5 is somewhere here. Okay, I'll make use of a different color. Yeah, let us say this is my 0.5. So corresponding to this, I'm going to get a strength, right? Yeah, now this is a strength, and let us say the strength is something. I hope you know what is 20 30 newton per mm square. Let us say 30 megapascal is the strength what I required, and we have done all the testing and all. Now during the execution, I want the 30 newton, and that is and 30 newton per mm square is the strength what I require in my structure. And for this strength, I have designed my entire structure. Now let us say while doing a concreting, let us say this is a site where you're working. Okay, and now while doing the concreting in the slab, what you have started to do, since you wanted more workability, you have started to add more water. So when you started to more water, what is going to happen? Since water is a numerator, so what is going to happen? This zero 0.5 may go to zero 0.7 on the site, right? On the site I'm telling, because I've added more water. So if you're adding more water, water cement ratio is going to increase. And if water cement ratio is increasing, you can see from the graph, let us say zero 0.5 was here, let us say zero 0.7 will be somewhere here. Now let me draw it. Zero 0.7 will be somewhere here. Now what is the corresponding strength you're getting? Here I'm getting 30, but here let us say the strength what I'm getting is somewhere close to 20. Now I designed my structure for 30, but practically what has happened, by adding more water, my strength has come down. So as a result of that, the durability and the strength of your concrete, the strength of your structure may not be achieved at the site. That is why always whenever you try to work on the site, make sure you're not adding any extra water. Just in case if you want extra, if you want to add more water, what you can do is corresponding amount of cement also we need to add. Why is that so? Because now, to put it in a better way, now let us say I'm increasing my water from 100 to 110. Okay, along with that, you try to add cement also. How much cement you are going to increase? If I'm adding this, again I have to increase it by 20. Let me do it as 220. Now you try to take the water cement ratio. How much it comes out to be? This comes out to be 0.5, right? So now what has happened? Previously also the water cement ratio is 0.5. Now also your water cement ratio is 0.5, right? So if it is 0.5, the strength will be 30 only at the strength, even though you added more water, even though your concrete is flowable now, right? You are able to work with the concrete easily. But what has happened from technical point of view, your strength is not compromised, your strength is 30 only. That is the reason, always make sure you don't add more water. If you're adding water, corresponding amount of cement has to be added. Yeah. So this is all about the water cement, water content, and this is how you have to understand about that. I hope all these things are clear. So in the next lecture we'll take up the other things and we'll try to understand them. So we'll see you back in the next lecture. Thank you.